Seni sir, let me introduce him. He is presently working as a professor in the Department of Hydro and Renewable Energy, IIT Roorkee. His main area of interest includes hydro turbine design, testing, optimal selection of SHP equipment, and optimization of SHP schemes, solar thermal energy storage, modeling of renewable energy system, and hybrid energy system. He earned many awards like Best Teacher Award, Bharat Jyoti Award, Dr. APJ Abdul Kalam Award, and he's also supervising more than 19 research projects, and many of them is completed and many of it is in process, sponsored by different funding agency. He delivered more than 150 guest lecture on different subjects. Many books he authored, and I would like to give more emphasis on this. He published 138 papers in Research Journal and published 209 papers in conference, seminar, and symposium. And more interesting is that he has more than 10,000 citation. Now I request RP Seni sir, you can share the screen and start session.
Thank you very much. Uh, and
You are audible, sir.
yeah, good afternoon to all the participants. And it's really great to me that you have invited me just to interact with the participants. And the topic is given to me that solar thermal energy utilization. Is clear? My voice is clear?
Yes, sir. It is clear, sir.
Yeah. So straightforward, I want to share this PPT. I hope that you can see this screen PPT.
Yes, sir. Yes, sir. Yes,
Okay.
it is seen.
So this I'll start this solar thermal energy utilization. Basically, you might have heard from other experts about the solar energy, which we consider that the solar energy, the prime source of all renewable energy. We can say that all renewable energy derived from the solar or the sun energy, and it's about you can say it's more than 50% the energy which is reaching to Earth's surface are utilized in direct form that convert the other resources, and only 47% the solar radiations which we are interested to tap directly and then convert that solar radiation in a useful form. As you know that it's the beauty with solar energy that we can convert this solar energy into heat, you can say thermal energy directly, and electricity is converted directly without having other system, like if you talk about the hydro, wind. So you can tap this hydro and wind. But first, get electricity, you have to convert these resources into mechanical energy, and then mechanical energy to drive the generator, and the generator generate electricity. So it's again a very, it looks magic that it's a fantastic thing that solar energy can be utilized directly into electricity. But under this talk, I will not be discussing this PV, that is different together altogether, but the solar thermal energy utilization. And this also you might have just got the information. This is there. I'm here to share that because as far as the India, we are fortunate enough that we have substantial, because the huge amount of solar energy or If you compare the potential of energy, uh, I'm okay. Hello,
Yes, yes,
hello.
yes, sir. You're okay, sir. You're okay, sir.
Can you see my picture also? Or
Yes, yes, sir. Yes, sir. It is
okay,
visible.
yes. So that as far as the potential of solar energy concerned, we are in that region that where almost the maximum solar radiations we have, and it's okay that this about 5,000 trillion kilowatt hour per year's energy. It's a dynamic figure because because basically the energy is coming from the sun in the form of the intensity, or that is a per unit area. So considering the area, how much you can spare to put the system directly related to area. So that figure has been estimated. That's about 5,000 trillion kilowatt hour per year. But if we talk about the intensity of solar radiation, and based on that, how much the energy or that we can get, it varies from 4 to 7 kilowatt hour per meter square per day. That means if you have a surface area of 1 meter square, so the about 4 to 7 kilowatt hour energy you can tap in India. I think it's varying region to region. So in which is considered the highest annual global radiation. Uh, it's I think in the range of that. Most of the highest annual global radiation is received. Of course, you know that this is Rajasthan, and even this land or the area to install the system also there. And most of it, India has solar radiation is 1,800 kilowatt hour per meter square. Considering this, how many days in a year we can, it's okay. So it's about the potential, so there's no doubt about the potential. We have a substantial amount of the potential. Now, this, as I told you, that there's two different routes. One is through, let's say, this directly electricity converts this to PV system, and another is the applications of solar energy through thermal route. The thermal route, again, we can categorize into two categories. One is that your applications may be of low temperature, say about 200 degrees centigrade or 60 degrees centigrade, 80 degrees centigrade. There were so many applications or so many, we have our need where we need that low temperature. And the second classification we get the high temperature. And the thing is that in both the case we need a different kind of system. Like we have a different kind of system, entirely different than the solar PV and solar thermal. But in the solar thermal also, your need is of low temperature, and it will require a different type of technology. And for high temperature, again, we have to have a different kind of technology. So depending upon your requirement, you have to decide which technology you have to use. One more thing here I want to say that in India in particular, I'm talking about if we compare the solar thermal application or solar thermal utilization in comparison of other countries like Spain and America. So still it is, this answer I asked so many platforms, but it was not given satisfactorily, because those countries we consider that they are based on the solar, or they're good in the solar energy generation. They have maintained some ratio between the PV and thermal. If you talk of the solar energy, some ratio they have maintained. But in India, if you talk about the solar energy mission or the Jawaharlal and this solar energy that time, based on their guidelines, we also put some percentage, or that means we have fixed the sum that we have to tap solar energy through thermal route also. But you can see that in the present scenario, of course, now we are talking about that gigawatt power generation from solar, but almost all from PV, through PV. That is the things we have to think about that why, what is the reason behind that. Of course, immediately I can say that this solar thermal route needs the real engineering, hardcore engineering, and it's time consuming, and I can say this real engineering. And as far as the PV system, it's basically the physics background, develop the material, and the simple fabrications to fabricate the panels. And now it's very easy to put the panels, just occupy the land and put the panels, and you start generating electricity. Of course, some issues are there for interfacing to that is again this electronic problem. But as far as the system concerned, so now that means if you're talking about if you are in hurry to develop the system, to install the system to generate the electricity, you can follow that. But some consequences you will have to face after some time if you are not just putting the attention, you are not having the attention of the we have to find out some reason what is there. So anyway, this is in the beginning I am talking about. Let us talk about the where is technology. Of course, I ask you, I request you that of course I will be discussing the basics of the technology. But if somebody wants to discuss or have some query about the research aspect in that area, what we can do, so they can ask me. I'll be very much comfort just to respond your questions. So anyway, then this already I have told you there are two routes. So my concern is this: the solar thermal applications, where directly we can convert the solar energy into so that we stay. I'm not going to discuss other things. It will be covered by other lectures. So as far as the application is concerned, so I think air heating is again I'm talking about that we are not aware about that. In what way, because the systems are there, research is there, based on the research, you can develop the product, but I don't know why, what is the problem? Let's say awareness, lack of awareness, we can say that. Crop drying, we are consuming so many energy, the heat energy, of course, in the industry I'm talking about. The cooking, of course, it's a very good example we have, but I don't know why, because now everybody talking about, okay, the LPG cylinder is of cost is 900 rupees, and what will happen then? But we are ready to afford that. We are ready to pay that. But we are not thinking about the other consequences. Cooking is a very good device that simply, I think it's 30, 40 years back, people, they have developed that, the solar cooker, So this solar cooker, I know even I have 3-4 solar cookers in my house, but I'm not using those. I'm just still using the LPG only for cooking. But it's there that we must think, at least it's a habit. It's a culture, or you can say because to develop the good habit, we call this is a sanskar. So we don't have the sanskar now. It's not the sanskar from the family, but we have not developed the sanskar to utilize the renewable energy, especially solar energy, which is available to us, very close to us every day. But we have not developed the sanskar. That's the good habit. So this is the classic example of this solar thermal application or utilization. Totally missing. Because we think that if we buy the solar cooker, so what will happen? That the people say that I don't want an LPG. That solar cooker cannot be substitute of this LPG. But we can say that if you can use the solar cooker, so that you can save a lot of money as well as the fossil fuel. And you know that what is the disadvantage of the fuel. This is like this. Similarly, distillation. So distillation things, okay, people are thinking nowadays, but still we are consuming the electricity. The high this distillation, of course, up to certain extent, in India, the hot water systems are working well, but still we need that. But still we believe that we should put the geyser, which is electrical geyser based. So these are the things. So high temperature furnaces are there. Air conditioning we can use in the different cycle. We can use this. Space heating and cooling, of course, water heating. That is the things I'm talking about. Okay, we are doing well here, but other cases we don't have this. We are not utilizing it. Then finally, this power generation. Still, I'm talking. That is I'm talking about. That the hardly we don't have, because nowadays we are talking about the gigawatt of solar energy system, but PV only. And we started some plants. I don't know that they are still working. They are working. They may not be working, and still they are under education system years, and I don't know how many years it will take. But we have to think. We have to search the reason why the other countries they are maintaining some percentage, at least 30, 70, 20, 80, or 60, 40. But here we are 100% power generation of solar energy through PV. Okay, that is then the basic things. As I told you, I'll start with the basic things. That means this for low temperature we have, or you can see the device which we use that that the name of the device is solar collector. I think again, if you are a academician, that you should not use this term for PV system. Don't say that the PV module, you should not call it solar collector. Solar collector terms can be used for the solar thermal applications. So that solar collector, again, based on the temperature, we have the flat plate solar collector. In this flat plate solar collector, this concentration ratio. That concentration ratio is simple. That means the area of solar energy interception. That means what is the area over which you collect the solar radiation. The absorbing, that means the solar radiation will be absorbed over the equal area, that the interception area and the absorbing area are equal. Then only I can say the concentration ratio is 1. So that system is known as the flat plate solar. And in this, what we have the basic components, very simple. We have the glass, it's a transparent cover. Then radiations can transmit it and then get absorbed on the absorbing plate. Then we can say the solar energy is converted into thermal energy there on the absorbing plate. Of course, the characteristics of material should be like that. The transparent covers must have the highest value of the maximum value of the transmittivity. Then only you can say that almost all the solar radiation can transmit it through the material. And the absorptivity should be there for the absorber. Once this heat is absorbed on the absorbing plate, then that heat has to be transported. Because I cannot go there inside the system and use that heat. I have to transport that heat to the load where I want to use. So I think in heat transfer, you know that the best mechanism to transport the heat is the fluid flow. That means if you allow the fluid to flow in the vicinity or close to the hot surface, then what will happen? That the heat will be transferred to the fluid, and then with minimum losses, you can transport that fluid to any locations, so the heat will be transferred. So that means then after absorbing plate, we have number of the fluid flowing passes. So in case of liquid, if the fluid is liquid, then we know that the heat transfer capability of liquids are more in comparison of air or gas. So in that case, to transport a certain amount of heat, we need less quantity of fluid. So that accordingly, there's no need to allow the huge quantity of water. A small quantity of water, so that the passage is very small, it's narrow, that is because we want to transport the So that means this is the things that means heat will fall, this solar radiation will fall over here, they will be transmitted and absorbed or the absorbing plate over here, and then those heat will be transferred to the fluid which is flowing through these tubes, and these tubes finally connected to the headers. Just like a, you can say the bus bar in the electric system. So that this is there. So that means there is the inlet, water flow through these tubes, get heated, and then it goes to it. So this is a very simple mechanism. Even that's why I'm talking about this very simple to fabricate, to handle, and that things the whatever heat requirement you can. So this is awareness. It's awareness, but nobody is, because until this we can afford this fossil fuel based resources. So these collectors further can be, as I told you, this flat plate collector is for low temperature, and the focusing type. Where I think what is the focusing type solar collector? Basically, if you need to get a high temperature, so that means you have to concentrate the incoming solar radiation. How you will concentrate? Because the solar radiations are of low grade. So how you can concentrate? That means if you collect the solar radiation over a larger area and then redirect those solar radiations over a smaller area, so that that energy which you have collected in the form of the solar radiations is absorbed over a smaller area, then the temperature will rise. That means that you have increased the concentration ratio. So that the system is designed, of course, in 1.5 hours. I cannot talk all the engineering, but you can ask me that if you feel that. So that means the temperature of the fluid depends upon the concentration ratio. That is nothing but, this concentration ratio is nothing but the area, the frontal area over which you are receiving the solar radiations. This concentration, I call this a concentrator where the solar radiation is falling, and this is the receiver. So this is the area of receiver. So that way, depending on the concentration. If I say that the area is double of this, then the concentration will be 2. If this area is 4 times, then it will be 4. If it's 100 times, it will be 100. So depending upon the combination of this concentration and receiver, we can enhance the concentration ratio, and accordingly we can have the higher temperature. So flat plates collector, as I told you, is liquid heater and air heater, because it depends upon the which type of fluid you want to use in order to transport the heat from the collector to the load. This is okay. Under this, I think, as I told you, that nowadays flat plate solar collector, liquid heater I'm talking about, is a water heater only. And now, as far as the technology and advancement, this flat plate slightly modified. Those are known as the evacuating tube. Now, this flat plate solar collector, under flat plate solar collector, evacuated tube solar collectors are used. What is this? That means the evacuated tubes collectors are built to reduce convective and because to enhance the efficiency. How you can enhance this is still work is going on. In case of liquid, I'm not talking about, but in case of air heaters, a lot of work is going on because the heat transfer capability of air is much lower than that. So how we can enhance effectively. So the people are working on the solar air heater. So each evacuated tube, I just tell you that it's nothing but, I think there's nothing to explain more. What happens, that means there is a small tube which is already there, this fluid flowing. Then after that, we can say there's an absorbing plate. This is absorbing surface I'm talking about. Then there is a transparent cover. And after that, one more transparent cover. And this is a toughened glass. That means this tube so that it should not easily broken. So there's toughened glass. Between this and this, there is a vacuum. They have created the vacuum in order to enhance the efficiency, in order to reduce the convective losses and the thing. So it's like, just like that, transparent and then absorbing and the fluid. So this is now very much popular, and these are available in standard size, say 100 liter per day, 200 liter per day, depending upon that. And it's very useful system. You can think about that, at least because the requirement of hot water of that order is very much for bathing and for washing. And what we do LPG or we do the heater, so that we can save this conventional source of energy. Uh, is it okay, or I have to change something more just mathematically? Or hello, participants, can you give me the response in between? Hello.
Yes, sir.
Yes,
Participant, you can
participant
interact
can
with me,
check
sir.
with
The session is open. You can unmute your mic.
So anyway, let me finish this way. So this is the things here. This I explained that. So no problem. Then basically, as far as the engineering point of view, that's why I'm asking that whether I should go in the mathematical expression or something like that. Otherwise, I can just discuss all this technology or the things. So here, this is a little bit confusing, but in simplest way, I'm talking about that what we have to do. So that means the solar radiation, say some amount is falling, is transmitted. That after transmission, it is absorbed, and that heat is. So this is insulating. With this side, we want to reduce the losses, all the kind of losses we have. From the top, we have the convection, and radiation also, but this side we have the conduction. So in this case, let me tell you that what is the scope, because you all are academicians. So if you want to work in this area for the solar thermal applications or utilization, so there is a scope of the solar aerators. So in that solar aerators, what is there? That means this construction is exactly similar to the hot water system or liquid heater. The only thing is, because we need to allow the small quantity of water to take the same amount of heat, but in this case, that if you allow the same quantity of air, that will not be able to take up that heat. So that means the thermal losses will be more, and so we need to have the more quantity of air. So that means the passage should be larger. So that we will not have the tube, we'll have the duct. So this is the duct we have, and this is the you can say transparent cover, and this is absorbing plate, and below absorbing plate there is a duct. Through this duct we allow the air to flow, so that the more area required, so more area is provided to allow the more quantity of air, so that this thermal energy or the thermal energy can be transferred. There is a insulation. So that means conclusion is that this heat transfer capability is small. So there are so many techniques. I have the next slide. So in that we can find out that, so it's there, that means you can read out all this thing to show that all the things, how we can express the thermal efficiency of the collector. That is finally with this expression. I talk about this with this expression. It's the simple based on the energy balance. Based on the energy balance means how much energy you can utilize. That means how much energy is converted from solar to the absorbing plate, and then finally how much energy is lost, rate of energy is lost. So in that case, if I is the solar radiation, that is what per meter square, and if I multiply this collector area, but we have two things in between, the transmittivity, so I have to introduce the transmittivity also, I have the absorptivity of the absorbing, I have to use this, and of course mathematically we have effective product in this. and then losses that depend on the heat loss coefficient. So overall heat loss coefficient is UL, then it will depend upon the temperature difference. What is the temperature difference? That means the absorbent plate. Of course, you have provided the insulation, but this the plate temperature is Tp and ambient temperature is A, so the temperature will be Tp minus Ta. So that is the QU, this net QU you have utilized out of this ACI. In this case, there is a one parameter we introduced that is known as the heat removal factor. Actually, this heat removal factor consider or consists of, or you can say, take care about all many things which is related to heat transfer, and sometimes it is very difficult to work out or to measure that. So that is considered the heat removal factor. So that means finally there is expression. I'm not going to derive that. So finally, if we introduce that FR, so that final expression will be this. This QU is equal to FR I tau alpha minus FR UL T F minus TA. So that is the final expression. And then if you divide this by I, that's the things. So finally, the equation for efficiency will be just I tau alpha minus FR also will be there. FR UL TI minus T. So this is nothing but we can say that this is the final expression, and here we can say that this is a straight line equation. We can say this. We can say the C minus plus minus FR UL, and this I call this X. So this is C. So I can represent the thermal efficiency with respect to this, because I have to divide this by, I will not be there, okay, because I have to divide this I, and I will be here. So that is T O minus T I by I. So this is the representation by straight line of the efficiency. So for any requirement of temperature right in the equation, you can find the thermal efficiency. Of course, this is there. So now the classification of solar air heater, because I'm just why I'm giving the focus on that, there is a scope of research in that. So the solar air heaters without storage, porous collector, non-porous collector, sensible storage, latent heat storage basis, and with storage. That means we can connect the solar array to this storage, and without solar array storage, we have porous collector and non-porous collector. I think see that. So performance enhancement method, the porous and non-porous I'm talking about. That let us see that. Suppose this is the duct here, and this is the absorbing plate, and this is the transparent cover. So non-porous means this duct, nothing is there. That is free, and that is non-porous type. And sometimes people they have studied that if this system is porous, that means put some material, and that there is an air gap between that, and if we allow the fluid, this fluid through this, so up to certain extent we can enhance the thermal efficiency. Of course, we have to sacrifice, we have to spend the extra pumping power. So that means there is always debate in that, whether in some cases the porous type solar collector air heaters are more efficient based on the requirement also. So that efficiency you can compare. So then this basically the area I'm talking, the research area is that what are the scope, what is the how you can enhance the performance, and why we need the enhancement, because it has poor performance. The efficiency in comparison of the liquid heaters. Its efficiency is poor, and scope is there because for drying or in the processing industry, we need the hot air. So there, if we can develop some efficient system, so what is the scope in the performance enhancement? So enhancing solar radiation flux. That is a simple thing that you can put the reflector so that you can enhance the incoming solar radiations. That is one aspect. Of course, there is not much research there. Only thing that is you have to design that. It will become the concentrating type solar. So reducing heat loss coefficient. That means because from the hot plate, how we can reduce the losses to the ambient and to the atmosphere. So in that use of multiple glass cover, we have the cases that it's not just one glass cover. We have 1, 2, 3. Up to 3 we can have. After that, otherwise it will the transmittivity will be reduced. So overlap glass cover. This is another arrangement of putting the transparent cover, the glass cover. Evacuated PTO collector, of course, that we have already developed that for air heater, but we can have for air heater also. We have developed the liquid heater, but we can have the scope to develop the air heater also. Use of selective absorbing, that is a material case. Use of honeycomb structure, that is for, you can say, as I told you, the porous type. And the double glass arrangement, that is also there. And enhancing convective heat transfer. There is a lot of scope in there. Use of extending surface, that is the fins we can say, but we have to take care about that. If you enhance the heat transfer coefficient by providing the extended surface, that is the fins, so simultaneously there is chances to spend more pumping power. So that we have to optimize that. So use of corrugated absorbent plate, that is also comes under the fins category. And this use of roughened surface, lot of work has been done and is still going on. I think you have the hundreds of study on this aspect, and still people are working. So I tell you here that I don't know how many people you are working in this area, solar thermal, but scope is that how you can bring the results obtained in the laboratory to the field. That is also an area of research, because so far people work just to analyze the performance, but they have not developed even the prototype. That where we are missing, where we actually why we are lagging in this solar thermal application, because we people, even myself also, I'm working a lot of work, a lot of things I'm working in this, but those results are based on the laboratory, and I'm planning because there are some young people they want to enter in this area. So what they can do, they just bring those results because still there is a scope that they can optimize that which results can be optimum. So by comparing that, they can develop a prototype, and still that your job is not over. If that based on that prototype you develop the product, that society will be benefited, because society needs a product, not a prototype. But we are working in the laboratory. This is on model only. So based on the models, we have to develop the prototype. The prototype is that this actual system performance can be assessed in the field, and based on that, you can develop the product. That comes again in the industry, and if the product is available, everybody will buy that. They will be. But I think we don't understand that. What is the laboratory model, model testing? What is the prototype testing, and what is the product? So that nowadays research are, I think, very much available. There's no doubt about that. Each and every aspect we are studying, but even we have not developed the prototype, and finally we have to develop the product. Then we can say that the society can be benefited, and if the product is available, then we can think that okay, Now we have started utilizing the solar through thermal. Otherwise, again, it is there and this because nowadays, why this PV area is now speaking up and is going just to megawatt? Because product is available, the modules are available, so that anybody can go put that module on their rooftop and start generating electricity, getting electricity. But related to thermal, products are not available. So there is research. There is research need required. Anyway, so these are the things we can have, and I know that these systems of the product are available in other countries. Of course, their requirement of low temperature heat is because they are cold climate things, the countries. So they are very much concerned about the heat energy, thermal energy. Here we are having this even not in cold air weather. We are not thinking about utilizing solar. Anyway, this here also because take this example. Take the example of the IIT Roorkee campus. We have a very beautiful and very good swimming pool here, and I know that even 15-20 years back we have worked just to because in the winter season that swimming pool is closed because of the weather conditions. I think Professor this Alpesh is there and you can see that. So most of the time, around 6-7 months, this is closed because of the. So research is not required. Only things we want to develop the product or the prototype, so that because the systems are there. So what is the harm if we connect this this swimming pool water with this simple flat plate solar collector? So anyway, so that scope is there. The only things you have to think about. Now, again, this is the solar thermal power where you need the solar concentrator. As I already told you, so this combination is different. This you can see that we can have this. So depending upon the temperature, this I have discussed already, but this I'm going to show you this. So here, this is there. This type of combination, the plain concentrator and this concentrator, the CR value, I can say it will be up to 4. And if you have this type of, there's a this is the plane, and this I can say this is tubular. So you can go 4 to 10 CR, and if you have the parabolic and there is a tube receiver, then you can go 10 to 100. And if you have the paraboloidal, this is just like a dish, and the spherical shape of the receiver, then you can go up to 10,000 CR. So very high temperature. But depending upon your requirement, so based on these combinations, the systems are available, but not in India. I'm talking in India, only funnel type is there. So these solar thermal power generations, we need the solar collector, and these solar collector are sometimes known as the focusing types or concentrating type, and there the receiver area is much higher than intersection area is much higher than the receiver area in order to have the higher concentration to have the higher temperature. So again they are classified as the concentrating type. So line focusing and the point focusing. So in line focusing, the parabolic trap, Fresnel trap. I think this in India, the people they are started working and they are working and they achieved up to certain extent. But plant, I think still it's time consuming, it needs hardcore engineering, it needs all the hot systems, moving components and everything. That's why we are not touching this. This is bad actually. Because something we have to think that after some time, some consequences will be, we are going to face some consequences. After some time, if we are ignoring this route of thermal applications and continuously going just to install the PV system. Now it looks nice that within 2 days, within 5 days, within a month, you can have a gigawatt or megawatt plants installation of the generation is started there. So that anyway, so that's the engineering. So point focusing that this tunneling that's there globally or in other countries, their standard products are there. But people here in India still we are working on this, but for just for other applications, just for cooking purpose, to steam generation for in the kitchen, but not power generation cooking. So that we may think about. So as far as the solar thermal power plant concerned, so I tell you say exactly because you know that in solar in normal thermal power plant we need steam, which will be used in steam turbine or gas turbine, steam turbine basically. Because the mechanical power, the mechanical power is utilized for generate electricity, drive the generator, and so here the steam is generated by utilizing the fossil fuel, the coal or gas or whatever they are. This is a conventional source of energy, non-renewable energy source. So the only thing is here we use the solar energy in order to achieve the high temperature heat through concentrating type. So that is known as the solar field. So only this system we need extra. Otherwise, this power block and everything is similar, even the same engine, because it's a steam is generated at a particular characteristics of practical quality, required quality. So the only thing so we can save the fossil fuels to generate the steam. Other system is similar to things. So these are the slides I'm quickly going on. That's if you need the low temperature, so flat plate solar chimney also, the solar pond also there. Medium, then which we have to go the parabolic trap or funnel type. This is the for medium temperature. And the high temperature you have to go the central tower and the parabolic dish. So what are these? I think then let's talk about this. This parabolic trough is, you know that this is the trough, this is parabolic shape, this is a concentrator, and at this focal length, there is a tube, so that the solar radiation get concentrated over the tube. So here this you can read this that what is the advantage intention. It's a line focus, linear receiving tube, water consuming concentrators, parabolic mirrors, heat storage. That these are the characteristics of this. You can read. Similarly, for this central tower, I think most of the plant I have seen in Spain on this basis. That is this is tower basis there. So there's a large, you can see a very high tower, very high tower, and over this is a receiver over here. So everything is there. There's no boiler, and everything is there. Only thing, these reflectors are there, like you can see on here. So these get reflected here on this receiver. So this receiver, everything is over here, and even you can extend just sometimes to enhance the capacity. So you can install the many people are doing that depending upon their availability, so that that can be enhanced. So this is the beauty with this. Then we have of course paraboloid, or you can say this string. Here the capacity is the constraints. That means most of the this is 20-25 kilowatt systems we have, and each disk has its own generating unit, and then they can be integrated on bus bar and can be connected to the grid. But these units have a smaller size for each disk. This cannot be very large, so accordingly the capacity of the power block is also smaller capacity in about 25 megawatt, generally 25 megawatt units. Then next we have Fresnel collector. As I told you, this is now this coming up in order to reduce the cost, and of course it is not a very high temperature. You cannot obtain about 400 degrees centigrade. You can get, but it's sufficient to generate the steam. So this is the things here. But the advantage that we don't have this the curved surface of the reflector or concentrator. It's a flat one and arranged in such a way that whatever solar radiation, it's a simple reflector, plain reflector could be, and it will be focus to this here, this receiver over here. Anyway, so this I've taken this some data that is still, I don't know, 1 or 2 plants are in operation, but still we are lagging behind in comparison to the previous systems. So the people, they have started, or the government, even they are just under their programs, the private developers, they have started developing thermal, but it's not, output is not good. The next thing is, I'll probably say, storage. The storage thing is, you know that the nature of the solar energy is intermittent nature, and you cannot have them always. It's very few hours in 24 out of 24 hours we have the energy. So even in off-grid PV system also the battery is must. Similarly, if you talk about this thermal route, even all the hot water system, we have the storage, because you can see that's a tank over there, that is a storage, because this storage is the field of the hot water, and this is insulated just like a geyser in your house, and the daytime sunshine will be there. That hot water is circulated by thermocyclic process. There is no extra pump is there. So through thermocyclic, it will heat it up and is stored. And then when you want to use this hot water, you can use this. So this is storage. So that means like this low temperature requirement, you need storage. So for solar thermal power plant, storage must be there. It's because I'm talking about that, because if you don't have the storage, so that means the frequently plant will be stopped and start frequently. And you know that comparatively, like hydro, it takes a lot of time. So that means it will be the problem starting and the stopping of the plant. So that means just to bridge that gap or that problem, we need to have to store the energy or to store the steam, and there are different type of storage out there. But as far as the low temperature concern, I'm talking about the research is going on, because we also need an efficient storage. So that storage further classified the thermal and chemical. So most of the work is going on the thermal aspect. So under thermal aspect, the sensible heat storage, that is very simple, and another is latent heat storage. So this is phase change. I think you understand that if your background heat transfer, that means suppose if you have a solid, some materials are there, some material in the form of the solid. If you provide the heat in that case, so they'll get melted, and so that means that is this heat is utilized to melt it, and then when you extract the heat from that, it will be solidified. So that means phase is change of the material. That is known as the latent heat, and the sensible heat means that the heat is absorbed in the system, and if you allow just another fluid in contact, to transport the heat, so that is the sensible heat. So liquid and solid, both. Liquid is of course this hot water system, all are sensible heat storage, and the liquid is there, and the solids also there. I think, is it okay? Hello? Because
Yes,
sometimes I don't realize that whether you are sleeping, listening, or what you are doing. But in this class, hello?
yes, sir, it is okay. We have spared 10 to 15 minutes for the question answers.
The voice is breaking. Okay, let me finish this course, and then we'll have the question answer. Okay, right. So that is here, this solid. Again, the research area, because what I am trying to discuss here, I'm not discussing the basic theory, basic working principle of that. I'm trying to create the interest. If somebody really interested to work in the area of solar thermal application. I don't know how many, but if some faculty really wants to enter or just to start or some gaps they find in solar thermal applications research. So I think that way my focus and my objective to discuss this is like that. So anyway, so that means every time I'm talking about that in solar thermal energy storage, it's very much needed nowadays. The storage, I think this is the hot area nowadays. This is a burning area, or you can say even our government is also working. They are asking the project on the storage. So storage can be electrical storage, electricity storage, the battery storage, of course. But in solar thermal, we need different type of storage. So under the storage, I'm talking about this thermal storage are classified latent and sensible. In both area, people are working. People are working exclusively for sensible, and they are working latent heat based thermal energy storage. And I tell you nowadays, they are trying to combine these two types of storage, that is known as the hybrid solar thermal energy storage. Because this sensible storage may have some disadvantages, this may have advantages. So that means you combine that so that one's advantage can be minimized and other advantages can be taken to that. And then finally, an efficient process or efficient thermal storage can be done. So people working in that also, in that area also. So the sensible heat storage medium is the liquid and the solid. This is already that we have the liquid water. Already we are using this water system. This molten salts, mineral, liquid metals, and the solid is rocks, concretes, sand, brick, material. This is these are the things are being used. Then similarly, this phase change material. I think with some materials they have the property to change their phase. So those materials can be used, but of course, now we have to use the material which is of course very efficient. Efficiency means the charging, discharging, and energy contents. These are the basic requirements. But of course, the cost also is the criteria. That means we have to select the proper material for phase change material where charging and discharging rate is okay, and their heat content capacity must be good or high, and finally it should be cheap. That is, the affordability should be there. So in that case, people they have used the paraffin mostly, and the salt hydrates also they use organic effect. And nowadays the peoples they are working to develop the nanoparticles material to compromise between the this charging, discharging, and the heat capacity and the cost also. So that means 2-3 areas can be combined. Sometimes people think that means it's not my area, but I always say that engineering is one. So that means if you are good in some area, so take the help over there or try to integrate the other area also, then it is good always. Or a group of different disciplines can work together so that you take any product, any technology, it requires a lot of different kind of engineering. So that means if I have the habit to work alone, so what will happen? I'll maybe the master in one area, but that will not be effective. If together, because this working group having different disciplines, then it is very fast. It will be very fast to develop a product. And ultimately, engineer's task is not to get salary, not to do research, not to publish papers, not to get a good score. Ultimately, our task is to serve the society. And society will be benefited if you develop the product. And the product can be developed by developing prototype. Prototype can be developed by doing research on the module and based on your concept. So I think if you follow this route, then we can say we are successful scientists or successful engineer. Because ultimately we have to serve the society. And I tell you that nowadays government is plan is thinking on this aspect only. Any project you can say nowadays you can say that the R&D projects are stopped, they are not sponsoring. So I can say the R&D projects, if those are for product to the society directly, so you will get the things. That's why I'm talking about any type of research you want to work in, you want to pursue in any kind of research, but your objective should be that how fast your research will be delivered to the society. So that R&D in solar thermal, which already I have talked on the while discussing the various type of devices, but here also that some R&D solar thermal systems is indigenous development of solar water heating system and solar cookers, full commercialization, well-established manufacturing base. So that's why this sentence does not need any kind of special research. Everything is there, but the only thing is based on that you have to develop the product. Second generation technology developed using selective coating absorber, that is also there. Number of modes developed for solar box type and construction. All the things are there, but the only things you develop the system of the product which can be used by the society. Of course, those products should be affordable. That is very important. That means one or two products you can give on subsidize or from your project, but ultimately it should be affordable by the common people. Chapter cookers for indoor cooking for large kitchen, that's there. That is, so far we are talking of the solar cookers, so no fun, but nowadays for generate steams, basically, of course, it is already there. Just generate the steam for kitchens, basically community type kitchen. There's a masses of the things, but those system if you can develop, which will be used individuals of that one household. Concentrated technology for steam generation and industrial process heat application. It is again that we are not thinking about. We are thinking about, okay, if somebody say that you just do the solar thermal power plant area, what is the scope in that? Okay, you just develop this, do some research to develop the concentrator or receiver or keep cavity or efficient or that is there. But I'm thinking that what for you are doing just to establish the solar thermal power plant. No, I'm saying that if you can develop a system which is based on the concentrating type solar and can be integrated to any food processing industry where comparatively medium temperature is required. Of course, it's more than 100 degrees centigrade, but not 400 degrees centigrade. Maybe 200 degrees, 150 degrees centigrade for drying process or any kind of process for food processing or any kind of process industry. So those things can be integrated because we know that those industries are consuming a lot of electricity in order to get the heat energy. Or they're using the biomass also. So that biomass can be used efficiently to generate electricity. But here the solar energy, which is free in cost everywhere, so that we can use this to reduce the biomass of the fossil fuel. I think this is the last. Now we have time. I think you can ask me the question in this area, and if one by one. It's okay. Thank you very much.
Thank you, sir. Thank you, sir, for wonderful lecture. Nicely touched upon various aspects like application of renewable energy, collector, particularly evacuated type solar thermal collector, performance enhancement methods, and correctly you differentiate between the line focusing and point focusing system. And you emphasize more on types of thermal energy storage and what is and R&D in the solar thermal system. Thank you, sir. And now the question answer session is open for the participants. So I am giving access to participant. Yes. Now you can raise the question. Participant, please, you can unmute your mic to ask question. Anyone, please. Participant.
Hello.
Sir, I have a
Yes,
question.
sir.
I am from West Bengal, Durgapur. My name is Dr. Saurabh Ranjan Das. I have a
Yes.
question. Is actually Dyson sphere possible?
Pardon?
Dyson sphere.
No, your voice is breaking. I'm unable to listen that.
Dyson sphere. Dyson sphere. Is it a
Yes.
possibility?
Some other person, if they are able to hear, then can ask the question on behalf.
Can I write in the chat box?
You can write, and he can read that the organizer permitted. He
Okay.
can.
Okay. Okay, sir. Okay, sir. He's asking that Dyson sphere a possibility. Is Dyson sphere a possibility? Yes.
Not not clear. I think can you write on the,
Just a second, sir. A second.
I'm not able to hear the term you are using.
Let me share the screen, sir, so you will be able. Can you read?
Is Dyson sphere a possibility? For in what?
Can it be made? I mean to say, can it be made?
Yeah, I think the possibility is there, but actually, again, you have to think about the efficiency and the cost. Yes, you can work on that, but I'm not come across on this aspect.
Okay. Anyone? Any other participant?
Use that. The only thing is the performance, because here in this area, the cost and the efficiency we have to optimize that. So basically, it should be affordable. That is the thing.
Any
So
other
that
question for participant?
Well, hello.
I don't have any experience in this. I have not worked on this aspect.
Hello.
Okay. Any other question? Yes, Sandeep, sir.
Hello. Hello, sir. This is Sandeep from Acharya Institute of Technology, Bangalore. Sir, I have a question for you.
Yes.
What are the problems with maintenance of thermal systems?
Yeah. This, I think in comparison of the PV that we have to maintain, this is a material. I think if you talk about the which type of solar thermal you are asking, because there are two kinds. It's a liquid based or it's an air based or the
Yes, it is liquid based.
yeah, liquid based. The corrosion is the basic things. So that means that again when you develop the product, so you have to keep in mind the material cost also, and then you have to compromise this corrosion. Corrosion is the basic problem in that case, and further because there's calcium and other things in the water, if you're talking about, so that get deposited. So that means the choking of the tubes or the passage, flowing passage is the main problem in that. Otherwise, if you talk about other things like the transparent cover and the other things, there's no problem.
I go.
Only, yeah. Hello?
Okay, thank you, sir.
Yes, any other participant, please?
Sir, what is the material of construction of the top
Myself.
cover of the flat plate collector?
One by one, please.
What is the cover top cover material of the flat plate collector?
Not, not able to hear. What is the
Cover material, top cover material of the flat plate collector? What is the material of construction?
can somebody help me in that?
So you can write the question in chat box so that I can place on the screen.
What is the material of construction of the top cover of the flat plate collector?
So what is the?
Sir, he is asking for a
that-
material of top flat cover, topmost layer of the flat collector.
What is the
Material used for
yeah,
the top, yes, for the flat top collector.
like the transparent cover you are talking about?
Right.
Yes, sir.
Yeah, I think that is there. That means if you talk about the transmittivity, you talk about the transmittivity because the characteristics of the top cover is should have the maximum transmittivity. So I tell you that in nature, if you have 3 to 4 mm thick window glass, so it has the maximum transmittivity. But the problem is again that is a handling problem, because if you want to transport the system with having the window glasses, so there is chances of this breaking. So then the people started working to create the toughened glass. So in that case, of course, the transportability is easy, but transmittivity get decreased. So that means the material is between the pure window glass and the this toughened glass.
And how to do the tracking of the sun in case of flat plate collector used for heating the building?
How?
How to do tracking of the sun in case of flat plate collector for heating the building?
The question is that how we can do the tracking of this collector, this flat plate collector you are talking about, the focusing type collector?
Both.
Both. I say that means for flat plate solar collector, the tracking system, the continuous tracking system is not feasible, economically feasible, or it is not advisable to have that, because the flat plate collector can collect both diffuse as well as the beam radiations. So in that case, the only thing is that means sun should, or the sun signs should be continuously falling on the flat plate solar collector, and for that I don't recommend that a continuous tracking should be there. Only thing, it should be the fixed installation, of course, at some tilt angle, having some tilt angle, and that tilt angle is near to the latitude, and the possibility to have the sun rays falling on the flat plate collector if you just face the collector either north facing or south facing. And for focusing type solar collector, that is must. That is must. You have to have the continuous tracking. and which is considered as a very complicated thing, and it's available. This tracking is required in focusing type continuously because it collects only beam radiation. So diffuse radiation will not come into picture, and beam radiation is always changing its direction, and accordingly you have to collect the incoming solar radiation and then redirect to the your receiving. So that is there. That means it's a very costly thing in that, that tracking. So all the focusing type uh, collectors, they have the tracking system.
Good afternoon, sir. Myself, Dr. Kunal Bhatt, and sir, it's an excellent session, and it's informative also. So thank you very much for this session. Sir, I would like to ask you that regarding solar photovoltaic and solar thermal, if we consider secondary generation, at that point of time, solar thermal offers higher efficiency. Still,
Yes.
more or less, we have find that it is not comes out in a real practice. Rather than there is exponential growth in solar photovoltaic. So, can you show your views on this?
I think
Sir,
you
many
might.
subsidies and that kind of things has been
No,
offered
no,
by government,
I
and
think
more houses are going to benefit
yes.
by solar photovoltaic. But still, peoples are not ready to go for a domestic utilization of solar thermal and that kind of thing. So,
Sir, I tell you, I think I started my talk with this query only.
yes, sir.
Even I will be thankful if you can answer. You people answer. I told you that from the very beginning, at all the platform, I used to ask these questions to the experts. Also, they are not able to answer this question. And
Sir, being a
then
potential person, you are
I
more
think
towards the policymaker also. So can you throw some
I,
light on that? That in nearby
okay.
future, is some policy that kind of thing will be framed that will promote this
Let me
secondary
tell
emission?
okay, I can answer this, but don't think it's a political, it's a very frankly I'm talking. It is the things that we are used to achieve our target in quickly and following the short route. That is one thing. This is our mentality I'm talking about.
Okay.
You got it? I think everything is in that.
Yes.
Doctor,
Even you start from the government to the end users, the same thinking we have. Even you start let me tell you, so don't consider this because it's not the political. It happens like this because the government wants to meet their target that they have installed this system. They have started in gigawatts generations through solar energy in 2 years, 1 year, or 5 years.
Okay.
So what route they will follow? They are concerned only to meet the target.
Exactly.
You got I think statement.
Okay.
I don't want
Yes,
to
sir.
answer.
Yes, sir. Okay. Now very clear, sir. Okay.
Think about the end users also. These things I continuously just I think try to address this question and this query. Even I just took the example of the solar cooker. Solar cooker is a very beautiful device and we can save a lot of energy with fossil fuel. This LPG. But do you
Yes.
think we are talking about is the cost of 900 rupees, the cylinder cost is now, but we can afford this, we are doing this. Even we are not thinking about, okay, if I can save 50% the LPG in the month, I can save 450 rupees. If I use the solar cooker in my house and some load of the, or some like this boiling the rice.
Conventional fuel saving. Okay.
I think you got it what I'm talking about.
Yes, sir. Yes, sir. Okay.
So that is the problem. So this is not the technical answer. I'm happy that you asked this question at least if this is the original query from your
Sir,
side.
if I recall the arena of early 90s, at that point of time, that subsidy will be offered to solar cooker also.
Yes. So I think now you can think about this. That do we need subsidy if you are this spending lot of money on LPG?
Yes, sir.
1,000 rupees we are paying for cylinder, 900 rupees.
Exactly, sir.
So we are not, that's why I use the sanskar, the habit we have to develop to use this. So
Yes, sir.
that is the thing. Yes, I
Okay.
agree with
Now,
this. That's why,
we
yeah.
have one more
Thank you. Thank
question
you so much,
from
sir.
Dixit sir. You can unmute your mic to answer question, sir. Dixit Praful Bhai.
Hello.
Yes. Hello. Mihir sir, your mic is unmute. You can question. Mihir.
Hello.
Yeah,
Hello, sir.
yes.
My name is Mihir Patel. So I want to ask you one thing. What are the technical challenges we are facing to adopt the parabolic trough collector in the India?
It's basically challenges is I can say that because we are not used to that. As far as the technology concerned, there is no problem. You are talking about the design aspects, installation
No,
aspects.
sir. I'm talking about to power generation. We are not adopting the parabolic trough collector type solar power plant in the India.
Even not others also. Hardly, because in the list I have given, there are so many lists, so many solar thermal power plant are listed, but I don't know any power plant is in operation. Hardly any. That's why, because it's okay that this some people they have started. I don't know how they started, but they are not. I use that. It's a hardcore engineering. It's a hardcore engineering, and even you can see that in your institute also, that how many students they want to work hard.
Yes, sir.
Everything software and the things. It's a real engineering. In PV, there's no engineering. I think you buy the module, put that at a certain angle, and then install it.
Yes, sir. Right.
That's why, because hardcore engineering means like solar, you have to start with the installation, you have to start there's operation, and then, but after that you'll get some advantages. I
Yes,
tell
sir.
you this. It's always, because the most beautiful things is that I can answer, but I don't want to open this because still I try to get the answer from others, because the storage, solar energy storage through PV, it's not possible to size the battery of that size or megawatts. But in megawatts, solar energy can be stored in thermal.
Yes, sir. Right.
Efficiency. So in spite of that, we are not coming up. That's why I just give the example, because I already visited the Spain and this USA hydropower, this solar base, and everywhere it's just like a garden in our area we find. So there's so many plants, and what we have found, that one plant is SPV based, next plant is totally based on that thermal base. And then we try to find out, we ask that, so they say that no, I don't know, they didn't give the answer directly, but they say that they have to maintain some ratio, this I'm talking about, 30, 70, 40, 60 or 20, 80. So that is the thing. So it's a storage, the advantage and the efficiency also. You cannot hardly, I think we are talking about the 20% efficiency of the PV. No, it's not even less than 15 degrees, 12 to 12, around 20%. I'm talking about 12%. I'm talking about, and in this we can achieve the 30%, more than that even.
Now we have one more participant. Dixit Pathak sir, would you like to ask question? Dixit Pathak. Dixit Pathak sir. Hello. Any other
Hello?
participant? Yes, yes, we.
Hello, may I speak?
Yeah, please.
Yes.
Yeah. Sir, I am Dr. Sardar Patil. Basically, I am not from geography, engineering background. I am from geography background.
Right.
So my questions are different types. In case of offshore generation of solar power, yeah, India is lagging behind, but we can find the sites. Does there are any possible threats for the same? I mean technical issues. Did you get my question?
The last part, please, that if somebody really wants to install the solar based
Yeah, in
plant
the offshore region.
offshore, yes.
Yeah, offshore.
Offshore, yeah. So that is now, this is the emerging technology.
Yeah.
I think I based that thing is the solar this floating.
Yeah, floating.
Yeah, so it's emerging technology. People started working on this. I missed that. But basically, it's a PV only. We are
Yeah,
talking
PV
about.
only. That is
Yeah,
PV only.
that's why I know that's why I missed it. It's a PV only. It's
Yeah,
a PV.
PV
I
only.
think
Sir, concerning
I was
the
worried that how I missed this emerging technology, but because of that is the and that comes under PV,
yeah,
not
PV.
thermal.
Yeah, PV.
Sir, can I ask one more question?
Please.
Sir, it has been said that for canal rooftop, if we go for, then that will deteriorate the evaporation rate, and subsequently it will result into shorter of rainfall. So throw some
Yes.
light on this, because these are
Yeah.
there is always positives with the negative background, and somewhat expert like you can throw a particular technological lights on that. So I would like to ask you this question, because it is a very tricky kind of question, and we can justify either side. So it is so nice of you if you throw some lights on this.
That the people they just developed some model based on a very small module systems. So that means still they found that some evaporations were reduced, and even they found that the output of the module has increased, enhanced. So based on that, they have developed some model, but it is not, as you told that you are telling, that so far no conclusion has been drawn that whether they should put the canal top or not. So because it's the question is that some reduction in the evaporation is there, but simultaneously they have enhanced the output of the module because of they were able to reduce the module temperature, the cell temperature. So there's no clear-cut recommendations that, but still people are working on. That's the thing I can tell.
Okay, thank you so much, sir. Thank you.
Now, any other participant?
Hello, sir. Hello, sir.
Yeah.
Sir, I am Dr. Devjit Misra from West Bengal. Sir, could you suggest household application, solar thermal storage for household application?
How we can?
No, for household application.
Household applications of solar thermal.
Household applications.
Yeah.
Solar thermal. Hello?
Yes, sir. I am talking about household application of solar thermal because I am living in a rural area. Often there is a power cutoff. So if we use solar thermal energy in rural area, it would be better for us.
So you want to just ask that what type of solar thermal storage you need, huh?
No. In especially rural area.
Yes, yeah, rural area. So that means I'm talking about the if your requirement of the hot water. Hello.
Hello, sir. Yes, it.
सर आप कंटिन्यू कीजिए, आप जो बोलते हैं सुनाई देता है, प्लीज कंटिन्यू.
Myself.
Yeah, please continue.
Because even I'm trying to just understand the question, otherwise my answer will be wrong.
उनका सवाल ऐसा है कि what are the applications of solar thermal, and that you already explained, that is solar cooker and other parts. You already explained that, sir.
I think he's more.
The same question he is asking again.
Yeah, it's storage. I think he's asking.
I think I'm asking about storage.
Yeah. So I tell you that if you want to, your need is the hot water. So all the hot water system, they this storage is integrated with that, because you know that the water tank is act as the storage only. You got it? I think. And if your application is for drying purpose, so I tell you that the simplest method is, or you can say type of storage is the sensible storage. This is solid base. Let me tell you, that's a very easy to, if you want to work in the rural area, to take a tank. Are you able to do that? A tank, and in this tank you just put the insulation around that periphery, and then put the rocks, small stones, and other things. Hello. Hello.
Hello. It is audible, sir.
Yeah. Then you have to have a solar aerator. That is also very simple things. That's a glass absorbing plate, duct, and everything is there. So, and you then need a fan. It's a pump, a small capacity pump, which can be driven by the you can say the solar PV. So, what you do that you integrate a solar collector with the sensible storage, which is not water, air I'm talking about. So that sensible storage is the most efficient and the cost effective. For smaller things, there is smaller requirement for a household. Hello?
No, no. Any other
Okay,
questions?
sir. Okay, sir. I understood.
One more thing I'll tell you. That is the only gap I told you that in this area is, let me finish with this, because lot of research is available, research results are available, and I will be happy that based on those results, if you integrate or if you can develop a system, or you can ask somebody to develop the system and install in an area, then it will help the research. It is one kind of research.
Okay, sir. Very good idea.
One more question, sir. How to control the temperature in case of domestic application?
How you will control the temperature in
Domestic application.
Domestic application.
a temperature of what?
Temperature of the hot water or hot air.
Yeah, it's always there. That is just like a thermostat you have in the normal geysers. Hello.
Okay.
You put a thermostat at the outlet and set it that when the temperature reaches 60 degrees centigrade, then it will open the valve and you can take the water.
Okay. Thank you, sir.
Any other question from participant? It's 3 o'clock already. Anyone? Okay. No, it was really wonderful interaction between expert and participant. So it's our honor to have you here, sir. On behalf of this organizing committee and participants, once again, I thank you for taking time out from your busy schedule. Thank you, sir.
Thank you very much, and I really enjoyed, because the session, I think the people, they ask the questions, so it's always good for a teacher. That means if the questions are there. If there are no questions, then I know that what we should think about the teacher. So thank you very much. Okay.
Thank you, sir.
I'm saying my thanks to Professor Alpesh also. Of course, you are using that his ID. Huh?
Yes, sir.
Thank you very much, sir.
Thank you.
Thank you, sir.
Right.
Actually,
Yes. So I have another SARC lecture now after this, and NHPC I just took up to 1 o'clock. Then had lunch or on this seat only, and then directly connecting to you. So I'm enjoying.
Thank you so much, sir. Thank you.
Thank you.
okay, sir. Thanks for your wonderful. Thank you.
Okay, so we have a break for 30 minutes and we will